Hey everyone, I want to talk to you in this video about how we quantify how spread out a set of data is. There's two ways. One is very simple, interquartile range, and then the other one is more complicated, but it's the one we actually end up using because it does a much better job doing what we want. So here they are. So notice I'm in measures of dispersion or spread, and right up here are the box plots that we did in the last video. So two ways, interquartile range. The interquartile range, or IQR, is literally just the distance between Q1 and Q3. So it's the third quartile minus the first quartile. It's how far apart they are, that's it. If you're looking at a box plot, by the way, it's the length of the box, part of the box plot, not the arms. It's just how long the box is. The reason IQR, so it's very simple, it's super easy to calculate, but the reason it's not used all that much is that it ignores all of the data outside the middle of the box. And so it doesn't tell you anything about how spread out the outer 50% of your data is, only how spread out the middle 50% is, which is not the information you usually want. The information you usually want is how spread out is my whole data set, my data set as a whole. And that's what standard deviation measures. So let's talk about standard deviation. Standard deviation is a little bit complicated. It is an average, and it is the average distance that your data, that at each point in your data set is from the mean of that set. So it's defined in terms of the average. So it is, the first thing that you have to do to calculate standard deviation is calculate the average of everything in your data set. And then within that, you find out how far each point is away from that average, and you average all those. And that's the standard deviation. That's the thing I said is actually slightly untrue, but close enough. If you think of it that way, that's the way you want to think of it. There is another very related statistic called variance, and variance is just standard deviation squared. I will explain a little bit more in the future what these things, what standard deviation is measuring and how we calculate it and why we calculate it that way. In fact, maybe I'll make another video just on that. So yeah, I'll put up another video in the same module about why we calculate standard deviation the way we do and what variance is. And that video is 100% optional. I will not ask anything about that. I'm not asking about that on a test, but if you're interested in knowing, I'll explain it. There are two kinds of standard deviation. There is population standard deviation and sample standard deviation, in very much the same way that we have population mean and sample mean, right? We use two different symbols, mu and x bar. And you'll find that's true for most statistics. There's a population version and a sample version. And the reason that is the case will be more apparent in the future, but basically you want to think of parameters as fixed and statistics as variable depending on what sample you have. And so you want different letters for them, right? So if you're referring to the mean of the population, which you're thinking of as fixed and unchanging, you want to have a different letter than if you're referring to the mean of the sample, which depends on which particular sample you took. So we have different letters for them. Same thing is true of standard deviation. So population mean, mu, sample mean, x bar. Population standard deviation, sigma, which I'll show you how to draw in just a second. Sample standard deviation, s. In fact, you can see it right here. Where is it? There. This is what a sigma looks like. That is a lowercase Greek s. And of course, then standard deviation for sample standard deviation is just lowercase s. I believe the calculator uses capital S. I'll show you that in just a minute here. I think I'm not going to bother showing you the formulas here. I'm never going to ask you to use the formulas. They're an interesting example of something that we see a lot of in the class, but it's not something that's relevant to you. And I found when I go explain the formulas, people's eyes just glaze over. So I'll put that in the other video too, about the formula for standard deviation, why it is the way it is, and what it all means. But for right now, the way you really want to think about standard deviation is it's how spread out your data is. The bigger number means more spread out. So let's go look at the calculator. So let me show you something real quick. If you go to, I gotta share a different screen here. If you go to, no, not that one. Where is it? Where's my Chrome window? Is there more? It's not showing my Chrome window. Oh, there it is. Sorry. If you go to this web address, and I've got this linked in course resources up at the top of the modules. Go to this vmvu.sbcc.edu, and that's VMware link, by the way, also in modules. You'll get to here, and this is a little installer, or I guess it's a splash screen for VMware, which is a piece of software that you can put on your computer, or rather, it's networking software that SBCC has installed to allow any SBCC student to access any of our computer labs from home, where it treats your computer like it is a computer in an SBCC lab, which is really nice. It means you can use all the programs that are on labs from home. It sounds a little bit better than it is because it's kind of buggy. For instance, the thing I'm going to show you, this is my second try at this video, because the first time I did it, the calculator bugged out and I couldn't get it back in time. And there was just a bunch of dead space, so I reshot the video. And so I'm going to show you, like, you basically have two choices here. You can install a little app on your computer, which will start up VMware and let you turn your computer into something very similar, or into basically a lab computer. Or you can run it through your browser. Now, if you're only going to do it once or twice, it's probably good. The browser's fine, and in fact, it works fine just in general. But if you're going to do it more often, I found this to be a little bit more stable version. Doesn't depend on your browser, and tends to work a little bit better overall. This is what I have on my computer. When you install this, this pops up a window that looks like this. Let me go ahead and pop it open and share it. Looks like this. Very, very boring, only one program. And when you open it up, it's going to ask me to log in here. This is my pipeline username and password. So I've got this. It's saying I've got an app running because I have the calculator running right now, because I'm going to show it to you in a second. I didn't want it to crash again. But notice that you got all of these programs here, right? These are all AutoCAD, you use MATLAB, all kinds of stuff. The one I'm using is this one, TI Smart View for the TI-84. Because it's literally just a calculator emulator. It just emulates the programming of the TI-84 on a computer. No problem, it just works fine. There are also employee and student. I don't know if you guys could see employee desktop or not, but student desktop, for instance, I'm not going to do it right now because it has problems with competing with Zoom on my computer. Like, I just ran out of memory. But the student desktop, if you went into the math lab when it was open and just sat down at one of the computers, the thing that you would see would be the student desktop. This is what, like, it turns your computer into one of the lab computers, which is a little bit awkward. And if some of you are having trouble doing it, if you want to do that at some point, let me know and I'll make a video on it. But it's not super nice to do for a couple of reasons. I do it all the time, but anyway, programs are here. You can use these programs. If you absolutely want to do this, I'll show you sort of the ins and outs of it, but it's a little tricky, especially moving files around and saving them, because it doesn't realize that your computer is your computer. It thinks it's in a lab somewhere, and so you can't, like, save to your computer, which is a little awkward. Anyway, if I double click on this, which I'm not going to do right now because, again, crashy, it will bring up this window right here. Bring up the calculator here. There you go, calculator. Yeah, I got my screen nice and big so you can see what's going on here. So let me show you how to do this stuff on a TI-84. A couple buttons on the TI-84 that you want to get used to because we use them a lot. One of them, unsurprisingly, is the stat button. We use the stat button a lot because it's for stats, and So that's what we're doing here. So that's what I'm going to hit. I'm going to hit stat. And I got some menus. The one I want is the very first option in the first menu, edit. And that brings me to my lists. The lists are where we put data. They do a bunch of other stuff too, but for our purposes, it's where we put data. So I'm just going to put some random numbers in here. 18, 7, 6, whatever. So there's some random numbers. I just wanted some random data so I can show you what the commands are. If I want to find the mean, standard deviation, and a bunch of other stuff, the quartiles, among other things, of this data, there's a button for it. It is also in stat, so I'm going to quit out of here. So quit is a really important button on this calculator. A lot of people try using clear to get back to the home screen. Clear deletes things. You don't want to hit that unless you are planning to delete a bunch of stuff. The thing that you want to get back to the home screen, the blank screen where you can just type stuff in, is quit. It's the second function of mode. So that's what I'm going to hit. Back to the blank screen. Then I'm going to go back to stat. And instead of edit this time, I'm going to go over to calc. And I'm going to choose one variable stats. So one var stats is a very commonly used command. It's probably our most commonly used. It's definitely our most commonly used command in statistics. And it wants me to put in which list, and then this says frequency list, and then it'll, we're at a calculate button here. Don't worry about the frequency list for right now. We'll return to that. We'll use that in the future. But for right now, I just want to put in what list I'm using. So the way you make an L1 or an L2 is they are the second function of 1 through 6. So second function of 1 is L1. I don't know if you can see that, but it's a little blue L1 up here, and it's blue indicating that you should use the blue second key to activate it. There's also a green one. This is, what is that, the Y? There's a green Y here. I don't know if it's clear that it's green, but it is. And it's green because you would use the alpha key to activate the Y. So the color up here tells you which of these two buttons, second or alpha, to use to activate that function of the button. I want L1, so I'm going to hit second and then 1. It makes an L1 for me. Frequency list, we're not using one. I'm just going to leave it blank. I'm going to hit calculate. And when I do that, the screen's going to fill up with information. There it is. So notice we've got X bar, that is the mean. It's saying X bar instead of mu here because the calculator defaults to assuming that you have put in a sample, right? You're not usually going to have population data. And so the mean of anything you put in comes out as saying that it's X bar. So the mean of the numbers that I put in is 22.4285. And the standard deviation, remember I said there's two different kinds of standard deviation, sample and population. The calculator does not know whether you have put in a sample or a population, so it just gives you both. And you have to choose. It's never both. It's never that like, oh, this is the sample standard deviation is this and the population standard deviation is that. No. Depending on what thing you put in, that's the one it is. I put in random numbers. I'm going to think of that as a sample. Like 95% of the time, it's S, because you usually don't have population data, so you're usually not going to have sigma. So since I put in a sample, S is my standard deviation, 23.797. Right? So that's my standard deviation of my data. There's more things down here. You can tell by the down arrow here, and they are the quartiles. Right? So if you remember from box plots, here's the 5-number summary. Just gives it to you. I'll calculate it for you. Very convenient. A good way to find 5-number summary. So that is how you do this on the calculator. Whenever you need standard deviation or mean, this is the way you want to do it. So again, let me just quickly do that again. Stat, because we're in stats, and then to calculate for one variable stats, it's under calc, and it's the first option. And the other very important thing to note here is that to put in data, stat edit is what you want. Now access your lists, list 1, list 2. That's what the L's are for, is list 1, list 2, etc. We will return to this screen many times, many times. This is effectively the like spreadsheet screen on Sheets or Excel. This is just where the data goes, right? The boxes are a little less distinct, but they're still effectively boxes. So let's go see how to do this on Sheets. Do I have, yes, Sheets, there it is. So here I am back in Sheets. This is my tree data. I don't know if you watched the other video recently, but this was the tree data from the notes. And in previous videos, we found mean, median, mode, first quartile, third quartile. I don't believe it has an IQR command in Sheets, but it's very easy to calculate. It's literally just third quartile minus first quartile. It's this number minus that number. And so if you want to actually find that, you can do it. You can make your own function. IQR is going to be this. Oh, I'm going to need to put equals this cell minus this cell. Bam, I did it. Oh, really? Exactly 5? Interesting. And like before, I can just take this and drag it over there. It calculates this minus that. So there's IQR. Very simple. We'll use it a little bit in the outliers video coming up. And then standard deviation. When I do this, you're going to see a bunch of different standard deviation commands. Oops, equals standard deviation. So this is the one we want, STDEV. I think this is standard. I think this is sample standard deviation, right? If I go look at this, standard deviation .s is for sample, and it just says standard deviation .p, standard deviation of an entire population. So it defaults to this one. I'm going to go ahead and use this just so we're sure which one it is. And this is telling us which list to put in, and then that's it. So standard deviation, I want to do A2 to A201. Oops, whatever, this is fine. This, I'm gonna cut that out of here and put it over there. Yeah, I put it in the wrong place. Let's make sure that's going in the right place. Yeah, it's still the same thing. Standard deviation. There we go. Okay. And then we can just drag that over there. So standard deviation of the data in the tree A column is 3.79 feet, which means the average distance from the mean, which is 27.6 feet, of all of the trees in this sample is 3.79 feet. That's what the standard deviation is. The way you really want to think of it is how spread out this data is. Is how spread out is this data, right? And it's hard to say, like 3.79, is that big? Is that small? Is that a large standard deviation? Is that a small standard deviation? It's not easy to tell. So the usual way that I do it, I don't know if this is common among other people or not, but the way I think about standard deviation is relative to the size of the mean. So the standard deviation here is significantly smaller than the mean. So I think of this data as not being all that spread out, which we can actually see if I, so remember, this is the histogram that we made of this. And this data is not like spread all over the place. It's pretty much clustered around the middle, right? And then far away from that, on the edges, there's really not very many trees over here, right? There's only a couple of trees between 36 and 38 feet, where there's lots of trees between 26 and 28. So the standard deviation here is not all that big relative to the mean, which tells us the trees, the heights don't vary tremendously. And if you think about like a grove of orange trees, right, they're all similar heights, right? And so the distance between the average distance from the mean to the height of each tree is not all that big because they're all relatively near the mean. So that's how I gauge standard deviation. Same thing here. And we can see that the heights of tree A, or the tree A heights, are more spread out than the tree B heights, right? Standard deviation here is 3.79 feet. Here it's 3.25 feet. Right? And so that's really how we're going to use standard deviation, is which thing is more spread out, and how spread out is it relative to the size of the mean. Okay, so that's calculating standard deviation, calculating IQR. think that's all I wanted to say about those things. Let's go back and check the notes real quick and make sure that I'm not forgetting something. Variance. Okay, no, we're not gonna. I'm not gonna worry about these. This is supposed to be a kind of funsy in-class activity. It's a little challenging, and we don't need to worry about it for right now. Yeah, so that's all I wanted to say about standard deviation. I'm gonna go ahead and stop the share and stop the video, and I will see you guys in the next one.